Hello, and welcome to our channel, your trusted destination for the latest breakthroughs, trends, and stories in the world of technology. Today, we turn our attention to Huawei, once a global tech titan, and now a resilient force, rising from one of the most challenging tech embargoes in modern history. The company is gearing up to launch its next-generation smartphone chipset, the Kirin 9030, expected to debut with the Mate 80 series later this year. But the real question is, how powerful is this new chip? And can it compete with the giants of the industry? Let us break it down. After years of sanctions that barred Huawei from accessing cutting-edge semiconductor tools, especially extreme ultraviolet lithography from Dutch manufacturer ASML, the company was left without a clear path forward in the chip race. But against all odds, it returned to the scene with the Kirin 9000S in 2023 and is now ready to escalate that comeback with the Kirin 9030. Sources, including the well-known leaker Digital Chat Station, report that the Kirin 9030 will deliver at least a 20% performance improvement over the Kirin 9020, which itself had already boosted performance by around 40% compared to the 9000S. That translates to a cumulative increase of 50 to 60% over 2 generations. For a company still denied access to the latest chip-making tools, this is nothing short of astonishing. As for the architecture, the Kirin 9030 is expected to maintain a 12-core CPU setup using Huawei's in-house Titan V120 high-performance cores and Cortex A510 efficiency cores. The GPU will likely remain the Maliun 910, although sources speculate Huawei might increase GPU cores or optimize driver-level performance, an area where Kirin has historically lagged. For example, the 9000S underperformed by about 20% in graphics, compared to the older Kirin 9000. In benchmark terms, the Kirin 9000S scores around 897,000 points on Antutu, while the 9010 reaches approximately 950,000. That means the Kirin 9030 could potentially breach the 1.2 to 1.3 million mark, rivaling Qualcomm's Snapdragon 8 Gen 1 from 2021. Not cutting edge, but still solid performance for upper mid-range flagships, especially in Huawei's massive domestic market. However, Huawei is still not playing in the same league as the top-tier chips from Qualcomm and Apple. Processors like the Snapdragon 8 Elite Gen 2, built on TSMC's 3nm node, and Apple's rumored A19, potentially built on TSMC's 2nm process, are far ahead. According to performance analysis from Phone Arena, Kirin 9010 single-core scores trail behind the Snapdragon 8 Gen 1 by roughly 30% at the same power levels. In essence, Huawei's chips are about 3 to 4 years behind industry leaders. Why? Because of manufacturing limitations. Huawei's chip production partner, SMIC, still relies on deep ultraviolet lithography, or DUV, instead of the more advanced EUV needed for efficient 5nm or 3nm production. To compensate, SMIC uses multi-patterning, a technique that increases complexity and cost by up to 50%, while lowering yield and increasing defect risks. Despite these hurdles, SMIC managed to produce the Kirin 9000S on a 7nm N2 process. It even developed a 5nm chip, the Kirin 9006C, used in laptops. Still, due to low yields, mass production is a bottleneck. That is why even flagship phones like the Mate 60 and Pure 70 have faced serious supply shortages. Kirin 9030 is likely to stick with the same 7nm N2 node, given SMIC's current limitations. Some sources suggest that Huawei and SMIC are experimenting with 3nm production, using DUV and a technique called self-aligned quadruple patterning, or CQP, but a reliable, scalable process may not arrive until 2026 or later. Adding to the challenge, Huawei struggles with securing modern memory components, such as LPDDR5X and UFS 4.0. International suppliers like SK Hynix have halted direct business with Huawei since 2020. Although Mate 60 Pro models have been found using SK Hynix memory, analysts believe those components were either from pre-ban stockpiles or obtained through third parties. And yet, Huawei presses forward. The company is pouring billions into rebuilding China's domestic semiconductor supply chain. Through its investment arm, Hubble Technology Venture Capital, Huawei has backed at least 28 semiconductor firms. It is working with Chinese alternatives to major equipment providers like ASML and Applied Materials, pushing China toward chip independence. From an ecosystem standpoint, Huawei is positioning itself to control the entire chip production lifecycle, much like Samsung. And as it optimizes its own chip architecture, we are already seeing improvements. Kirin 9020 featured circuit design changes that enhanced efficiency. Kirin 9030 may continue this trend through higher L3, cache, improved NPUs, or better software-hardware integration. Still, the Maliun GPU line remains a relative weakness, trailing Qualcomm's Adreno and even MediaTek's Mali-based solutions. In summary, the Kirin 9030 is not about setting performance records. It is about strategic survival and national resilience. It represents Huawei's determination to carve out a future for itself, using domestic resources and unconventional tactics. While it will not outperform chips built on 3 or 2 nanometer nodes from Apple or Qualcomm, the Kirin 9030 is good enough to keep Huawei competitive, especially within China, where brand loyalty and innovation under pressure still win customers. Thank you for watching. If you enjoyed this deep dive into Huawei's chip comeback story, make sure to like, subscribe, and turn on notifications. We will keep bringing you the most insightful tech stories right here. See you next time.